Bismillahirrahmanirrahim. Assalamu alaikum. This is Khandker Jamil Ahmed. I am a master student of ECE department in International Islamic University, Malaysia. I would like to present a video presentation on light emitting diode, which is LED. This video contains history of LED, what is an light emitting diode, working principle of LED with band diagram, how does LED work, colors of light emitting diode, types of light emitting diode, applications, advantages and disadvantages of LED, customization of light emitting diode, conclusion. History of LED. LED was first invented by Professor Nick Holoney Jr. In his research, he found that LED is a form of semiconductor which emits light in some particular conditions. He used aluminum gallium arsenide on a gallium arsenide substrate. Entirely pure form of aluminum gallium arsenide cannot produce electricity due to their perfect bonding between their containing and surrounding atoms. By doping process, he created the change. The first invented LED was red. What is an LED? A LED is a heavily doped PN junction. It emits light when the junction connected into forward bias condition. Moreover, it is a device which converts electrical energy into light energy. Structure of LED. An LED consists of three components: an anode, the positive wire, and a cathode, the negative wire, and semiconductor crystal in between them. It follows the principle of electroluminescence, which is the ability of some materials to emit light when current flows through them. As you can see in figure 2 and 3, there are more components in LED, but they are only for protecting and focusing the LED. How does an LED works? An LED always operates under forward bias condition. That means P-type material connected with positive side of a source and N-type with negative side of a source. As a result, electrons move N to P and holes move P to N, so that the minority charge carriers are collected near the junction, and this minority charge carrier combine with majority charge carrier of the region and release energy. In figure 4, we can see the working principle of LED. Photons must have equal energy with the band gap of semiconductor. This is how electrical energy converts in light energy. In figure 5, we can see the recombination process of LED. In this process, diffusion potential, and which is denoted by Vd, its value is determined by the Na and Nd dopant concentrations, and the Ni is equal to intrinsic carrier concentration of the semiconductor material. And the equation is Vd is equal to Kt over Q ln Na into Nd over Ni square, where K is Boltzmann constant, T is the absolute temperature of the semiconductor, Q is the elementary charge of an electron, Nd the concentration of the free electrons on the n side, and Na the concentration of the free holes of the p side. An LED is also essentially a p-n junction, which is constructed from an energy bandgap semiconductor, such as gallium arsenide, and in which the recombination of the electron-hole pairs results in the emission of photons. The energy of the photon is hV. Then the equation of the emitting photon is equal to Eg is equal to E photon is equal to H into V, where Eg is the energy gap, E photon is the rate of the photon emitting photon. Vi characteristics of LED. When the voltage V is positive and greater than a minimum threshold voltage Vt, then the diode is said to be forward biased. A forward biased diode will conduct current. As with the resistor, the diode is completely characterized. Once we know the relationship between the voltage and current, the diode's Vi characteristics satisfies the following equation, which is I is equal to I naught e to the power qV over kt minus 1, where q is equal to the charge of an electron, K is equal to Boltzmann constant, T is equal to the material's temperature Kelvin, and I naught is the reference current, usually very small. In figure 6, we can see the Vi curve of an LED. In figure 7, we can see the Vi characteristics for different types of semiconductors. In room temperature, T is equal to 300 Kelvin. We can see the characteristics of Vi curves for different types of semiconductors. Working principle of LED with Venn diagram. From figure 8, we can see the p-n junction under unbiased and biased condition. Now I can describe the situation in this figure. In this figure, under forward bias, majority carriers from both sides of the p-n junction able to cross the depletion region. In this situation, the majority carriers become minority carriers. The minority carriers will be larger than minority carriers injection. Minority carriers will diffuse and recombine with the majority carrier. For example, the electrons as minority carriers in the p region will recombine with the holes. Holes are the majority carrier in the P region. The recombine causes light to be emitted. As we know, a light emitting diode consists of PN diode, which is designed so that radiative recombination dominates. Homojunction PN diodes, heterojunction PIN diodes, where the intrinsic layer has a smaller band gap, and a PN diodes with a quantum well in the middle are all used for LEDs. We will only consider the PN diode with a quantum well because the analytical analysis is more straightforward. Colors of LED. Since the eye is only sensitive to light with photon energy from 3.1 electrical volt to 1.6 electrical volt. Compound semiconductor materials composed of column 3 and column 5 elements are the materials of choice for LEDs because they have the direct bandgap properties and energies necessary for efficiency producing visible photons. Here we can see the equation of wavelength. In figure 9 we can also see the wavelength to relative eye response. The material used in the semiconducting element of an LED determines its color. The two main types of LEDs presently used for lighting systems are aluminum gallium indium phosphide alloys for red, orange and yellow LEDs, and indium gallium nitride alloys for green, blue and white LEDs. Slight changes in the composition of these alloys change the color of the emitted light. In figure 10 we can see the comparison of chip technology for wide angle and non-diffused LEDs. In figure 11 we can also see the wavelength of different type of semiconductors. LED properties efficiency. We can easily calculate the efficiency and the optical properties of LED by these equations. Here we can see the summary of LED types. There are two types of LED: miniature LEDs and high power LEDs. There are 12 types of LED parameters. First of all, luminous flux. Second, efficiency. Colorated color temperature, CCT. Color rendering index, CRI. Standard deviation of color matching, SDCM. Starting time, run up time, light distribution, color spatial uniformity, LED chips case temperature, lumen maintenance, noise measurement. Applications of LED. LEDs are now used in a large number of devices, markets, and applications. Their high reliability, high efficiency, and lower overall system cost compared with the lasers and lamps take these devices very affordable and attractive to both consumer and industrial segment. In this slide we can see some applications of LED. They are sensor applications, mobile applications, science application, automotive uses, LED signs, illumination indicators. There are many advantages of LED, such as energy efficient. LEDs are now capable outputting 135 lumens per watt. Long lifetime, rugged, no warm-up period, not affected by cold temperature, directional, excellent color rendering, environmentally friendly. These are the advantages of LED. Also, you can control LED by yourself. There are also some disadvantages of LED. LEDs are currently most expensive. LED performance largely depends on correctly engineering the fixture to manage the heat generated by it. It must be supplied with the correct voltage and current at a constant flow. Color changes due to age and temperature. Islamization and LED. To regain Muslim Ummah's heritage and their glorious past, we must start Islamization in science. Quran is a source of science. Allah said that, O children of Adam, take your adornment at every masjid, and eat and drink, but do not be extravagant. Indeed, He does not love the extravagant ones. Ayat al-Araf 7.31. Islam does not permit anything used unnecessarily. It is scientifically proved that night emitting diode saves energy than any other man-made light sources. Moreover, energy should be stored for next generation. This is how Islamization of science inspired the mind to Muslim become torchbearer who can push forward the frontier of Islam to regain the Islamic tradition of excellence and mastery in all science. Conclusion. LED is the technology of the future. Because of their advantages, LEDs provide great benefit for the users. LED technology, however, also asks for better communication from the industry in order to demonstrate the advantages of the LED over conventional technologies, partially because of its greater complexity, the long life and attractive design of LED luminaries, and the many possibilities for use make the LED unique and confirm the decision to purchase. LED creates individuality, and that is exactly what the world needs today in the future. Here are the references. Thank you for watching this video.